So my next presentation is on perceive, act, and plan phases in MIDCA, and the relationship between these phases. So first, I want to show a demo on Baxter and MIDCA. So before that, so here Baxter is asked. The goal for Baxter is on a red on green, and so now Baxter is during planning time, and someone come and put another block on top of the red block. So the environment changes, and Baxter can see the change and refine the plan, and now you can see it execute the modified plan in the new environment. Yeah, it's faster, but you can see it's not that precise. So it stack blocks, but I mean it's not perfect. But I mean, yeah, the lighting affects its performance and just other factors. But he did a good job in this demo. So in the rest of my presentation, I will talk about the demo and how it works, and just talk about the more detail on the demo that you just saw. So first, I want to just go over ROS, and ROS in robot operating system that we use here, and is a like other operating system. It has hardware abstraction, and it manages the message passing between the processes and other stuff. So three main concepts that you might want to know about ROS is ROS nodes. Any executable that uses ROS to communicate with other nodes. So if you
we have a question from Matt about the Baxter.
Okay.
Do you want to answer that now?
Yeah.
So he said, oh, never mind. Just continue. He said he's never mind. He's seeing it. His answer.
Okay. So as you can see here, I put two examples here. That this one is start a node. So initiate a node. The name of the node is Baxter command. Oh, before that, every ROS node is like doing a specific action. For example, moving Baxter arm it can be a ROS node, or moving his head can be another node. So a node is like just something that do a specific task on the robot. And so this, so as you can see, we initial a node here, and this node subscribe to a topic. Voice CMD is a topic, and so we subscribe to that and to that topic, and it listens to see if anyone sent any message over the topic. And so if it receives any message, it will go to message callback, and it process that message and will do further stuff. As you can see here, is another node that it published that topic, and it will send a message, pick up the red block. So string is the type of message, and voice CMD is the name of topic, and this is the message that it will send to whichever node that listens to that specific topic. So this is how different ROS nodes communicate and in ROS. So we use Baxter Research Robot, and it has, I mean, just a few details on Baxter. It has 3 cameras, 2 on his wrist and 1 on his head, and he has a sonar sensor that we don't use that yet, but we use Baxter's right-hand camera to observe the table, and use the other hand to execute actions. And and another thing, when you given a location to Baxter, it will find a sequence of joint to move the arm to that point. So we don't have to worry about that. We just give the location to Baxter, and it will find a sequence of joint to reach the point. There's just like highlights about Baxter robot. So now I want to talk about act and perceive phase, and the interface between these two with Word. Matt actually started working on this API. So we developed an interface between MIDCA and ROS. This interface is responsible for sending messages from MIDCA to different ROS nodes, like the low-level ROS nodes that we designed, and also like if MIDCA wants, if you want to just move Baxter arm, you will send a message to ROS node. So MIDCA will send that message to ROS nodes, or it receiving messages from ROS too. Like we have a object detection node that use a simple object detection algorithm, and it will detect the objects, and it will send a list of detected objects to MIDCA. Here I put a piece of code here that if you want to use MIDCA with Baxter, you need to create a ROS MIDCA object, and you have to define all the incoming and outgoing like topics. So for example, here object position, this is a topic that we send the detected objects to MIDCA. So we have different handlers here. These are 3 input handlers that are listening to these topics, and these are outgoing message handler that send out messages over these topics to other ROS nodes. For example, here this is we will through this outgoing message handler, we send location of an object that we want Baxter to move toward and just grab an object. So what happens in MIDCA when it works, when it receives messages from ROS? So here you can see it's kind of tiny here, but someone will just say pick up the red block. So those handlers, actually we have a ROS node that convert the voice to text to string, and we'll send it to MIDCA. So it sends a pick up the red block, and those handlers put them in the partition of MIDCA memory, and Perceive will have access to those messages, and will process them and store them in main memory. And also, as you can see here, red block XYZ is the location of the red block that it will send to MIDCA, and Perceive create a symbolic representation of that and will store in the memory. I will explain it in the next slide. Interpret will checks for any verbal instruction. Like here, we tell Baxter pick up the red block, so we generate the goal holding red block, and it will store in goal graph. And intent will choose that goal to accomplish. For now, we just have one goal, I guess, in this that works. And plan here we use PyHub planner, and it generates a sequence of action to achieve the goal. So for picking up, it generates reach the location of red block, grasp it, and then raise the arm. So each action is mapped to an executable method for the robot. Each of those methods can send out messages to ROS nodes. For example, here is reach red block. It will instantiate it to another method. That method can send out the message to another ROS node that is responsible for moving Baxter arm. And when that node receives the message to move to a specific location, it will move the Baxter arm to that location. Yeah.
Why is it? So it says reach, that's alpha 1 in the lower left. It says reach red block, but then it says alpha 1 is find X.
Oops.
Is that a typo?
That's a typo.
Okay, I thought so.
Yeah, that's a typo. And then this is, and then each cycle we execute one action, and yeah.
Can you repeat my question just to be clear?
Yeah, Mike said what is that find X, that alpha 1 find X, that's a typo here. So yeah, alpha 1 is reach red block. And one other thing I want to mention here, when we want to execute an action, it will wait to receive a feedback to just see if that action is accomplished successfully or is it a failure. So it waits like a few cycles to accomplish that that action like successfully. As I mentioned, we use Baxter right-hand camera to observe the table, and so this image is received from Baxter camera, and we have a simple object detection node that will detect objects based on their color. And so for now is a 2D image because Baxter gives us a 2D image, but we might just use a Kinect camera later and just have 3D images. So we have so that object detection node will detect the objects and the environment, and will send the list of objects to MIDCA, and that node is constantly running and just send messages every like 5 seconds, I guess. And and then in perceive we
5 milliseconds.
I guess 5. I'm not sure. I need to double check. But there's an interval between that it send the objects on the table. And perceive will create a symbolic representation of the environment. So as you can see here, it will say the green block on top of the red block, and green block is clear. So it extracts these predicates based on the distance between the objects. So it's kind of simple now, but we might change it later too. But this is like a simple example that we wanted to just make it work to just get an image and have a symbolic representation, because MIDCA and its planner work with a symbolic representation. And now I want to talk about the plan and perceive and the relationship between these two, which is my main focus of the research, my research. So as you saw in the demo, Baxter was given a task, and in the middle of planning, someone changed the environment. So we want the planner be aware of the environment while is generating the plan. So the planner generate monitors monitor for each action that it adds to the plan, and these monitors will call perceive, and perceive will notify the planner if something changes in the environment. Like as you could see, that someone put the blue block on top of the red block and make red block unclear. So the planner has to know about it, because otherwise the generated plan is not valid in the new environment. And also monitors focus vision. So we don't want to see, like, if there are 1,000 blocks on the table, we don't want to tag and observe everything on the table. We just want to focus on what is relevant to the plan. So so as you can see, the relationship between these two, plan, focus vision, and also vision helping planner to just be aware of the environment.
One question.
Yeah.
If there are 2 green blocks, our goal is like keeping red block on green block. If there are 2 green blocks, how it will decide which green?
Someone asked if if there are 2 green blocks on the table. So for now, we just assume there is 1 green block on the table. So that part is not irrelevant to my research. We more focus on if anything changed, the planner should know about it. And yeah, Mike.
That is a good question. We've talked about it, and that would, if the human actually said pick up the green block or second on the green block, should recognize that that's anomalous. There's ambiguity there in that speech act, and generate a goal to ask the user, which block do you mean? That's really what should happen. But I'd like another student to work on that, and we've done it simple, but that's a very good question.
Mm-hmm.
And you might give me a brief statement to the audience of what I just said.
Mike said that's a good question, and if someone if there are two green blocks on the table and someone just said, okay, stack green block on the red block, we should ask the user which green block you mean. So which will be another research area for another student. So he needs another student. So yeah. So this is just an example to just clarify the monitor idea. And so as is like the demo that you see with Baxter, there are 3 blocks on the table: red, green block, and red, green, blue, and the goal is red on green. And so the plan will be pick up red block and stack red on green. But as we saw, and someone put a blue block on red block, so the environment changes and monitor fires, and it will add the 2 steps to the plan to make red block clear, and then just generate the rest of the plan. So as you see, we develop an interface between MIDCA and ROS that lets MIDCA to communicate with a robot. Like here we have Baxter, and we create a symbolic presentation of the world after raw images. And our goal is developing a framework for fully integrated planning, goal management, execution, and vision in dynamic environments. So we want the robot to be aware of the environment while it's executing the plan, while it's given the goal. So something might change in the environment, and the agent just has to drop the goal or change the goal. So that will be our future research. Any question?
I just want to wait a second if you ask any questions.
Okay. Anyone else has question? Yeah.
Can you say a general statement about the relation? How does planning help perception and vice versa? Can you make a broad statement about that in this at a very high level and restate my question?
Yeah. Mike asked, give an abstract. Explain about the relationship between plan and perceive, right? So, as a planner will focus vision, and vision help planner to be aware of the environment while it's generating the plan. That's the idea. Good.
Other questions?